hard copy. You got a hard copy already, but I made a new one.
Good morning. We're just getting settled in right now. We should be having our speaker up in a few minutes.
Yeah, I know that.
Yeah.
Yeah, that's fine. I'll just email them all again. Okay. That's good. And I got an email from John that said that. So, should we good to go?
Good.
It's a little bit. Well, he's already.
Oh, yeah, so we're starting down already?
Well, no, we haven't.
No. Oh, yeah. Oh.
Yeah, I'd say. You know what? Well, he's-
We're gonna get started.
Okay. Yeah, that would, yeah, that might be. Should be just that bottom one right there. There you go.
We're gonna get started this morning to save time. Christine Clark and Jim Friedericks are here with VAS and Egg Source. And before we do that though, I'm Becky Wagner. For those of you who don't know me, I'm the agronomist for Land and Water Conservation Department. And our outreach marketing specialist, Zach Laughlin, is behind the camera or in front of the camera right now. And Halmerton, all these syllables and last names.
Sorry.
She is one of our soil conservationists, and then Paul Tellard is our county conservationist. So we would like to welcome all of you to our very, very first meeting of this kind. So think of yourselves as the trailblazers. We launched this program. We launched this program a year ago. And how it all kind of started, we were just talking about, we wanted to initiate some type of a soil health, take the nutrient management planning implementation to the next level, and we thought soil health was the next level. And so then Zach, being his proudness with being on Twitter and social media, he outreached and found some different practices from other farmers throughout the whole entire corn belt. And that's how we came up with some of the list of practices that you guys picked to do your practices this summer. But we added now onto that for our year 2. So we'll have a menu of different things you can pick from. from for this coming growing season. So, so with that, I don't want to waste any more Christine's time because they have a really good presentation to explain what we all tried to do this summer with your soil health. So Christine, thank you for driving up here down.
Yeah, thanks, Becky. Really excited to be here, and I am from Wisconsin and know the Fond du Lac area quite well. And then we'll have my coworker Jim coming in on video from Iowa, and so he'll kind of do his introduction as well. So we wanted to bring some information right from the lab, which was who Becky and her team partnered with for the soil health test, and just kind of help you understand some of the information that you got from year one. And then Jim also has some cool information that he's been working with some groups for a little bit longer time, and we can see how it overlaps a little bit.
Uh-oh.
All right, thank you, Zach. So to continue again with soil health, all over the country, we know that some soils are worn out, depleted, exhausted, almost dead, but I assure you there's comfort in knowing that your soils do possess this ability to restore themselves and come back to this really productive power, provided you do a few simple things. And this was from C.W. Burkett back in 1907. And we know a lot of your farm fields have been farmed and in agriculture for a long history of each of your own operations. So you might be thinking, Chris, is it really that bad? I dug into some information from the USDA land aggregation overview. And some of the things that they had in there that I found pretty eye-opening was that the productivity of some of the lands worldwide has declined 50% due to soil erosion and desertification. And the estimated annual cost of erosion to agriculture in the US alone is $44 billion per year. So that's about $100 per person. And then just kind of put that in perspective is a lot of your best topsoil has probably already left your field. And we don't think in the time frame that soil happens. Soils take quite a long time to be formed, and so we want to protect it and keep it in your field so that you can continue growing your crops. And it does some keeps your nutrients and stuff there too for you. So globally, it's a $75 billion or 75 billion tons of soil are being lost through erosion, and that is definitely a costly measure. So then some research from Schumacher in 1994, because of some of the things that were happening with soil health or soil erosion and that kind of stuff, it was referring to yield reductions of up to 20 to 40%. And that's specific to Midwestern states. So that's getting pretty close to home. And then soil compaction is definitely a worldwide problem, and that can reduce yields as well. This is from an Erickson study of 25 to 50%, and that's both in Europe and in North America. And then your on-farm losses through compaction in the United States is 1.2 billion per year. So that's why NRCS, they look at soil loss, they look at what's happening per field, because of all of this adds up. So how is it actually happening on your farm? So I think this is a really good visual for it, because it is happening on a lot of fields, and it's been happening for a really long time. So it does occur when there's tillage, and we know that we're using our fields every year to grow a crop. And then we've gotten better and better. Our equipment is taking away some of the crop residue, or we're harvesting more of that and finding other uses for it. So there's less soybean residue left behind. You might be baling that up and using that for bedding or some low-cost feed. Then it spirals down, and then the result of that is there's less soil organic matter. So every time you add oxygen to your soil, that causes organic matter to be used up in a way, shall I say. The oxygen mixes with it, and you have the ability to then increase erosion and compaction, because your aggregates have broken down. Those aggregates are formed by soil life that would be present there, and I like to describe it to a lot of people as like the slime that kind of keeps your sand, your silt, your clays together. It really comes from a lot of the root material, so what's happening underneath the soil layer, or worm channels and fungus and different things that are happening from that very important soil life. Once the aggregates break down, then you will probably already have noticed that your soil is creating like a crust on the top. And that is because the aggregates no longer hold themselves together, and the pore space is gone. Usually that pore space is filled with water if we've had moisture, or as it starts to dry up, that just becomes airspace. Usually want it to be like 50-50. But once you have that surface crust, then it just adds to more. So the next time that it rains, it has the tendency to just coast across the top and not infiltrate down and stay in your field. So that's definitely why we have a lot more erosion being caused and coming out. So the decrease in the infiltration, you then get more wind erosion, because some of those fine particles tend to migrate to the top. And then water definitely is going to continue to wash it away. So that then continues in number 6. You just still have more soil organic matter and more nutrients and topsoil loss, because erosion becomes more prevalent. And then you get more ponding. So even after what you don't think is a substantial rainfall, if you get ponding in places in your fields where maybe years ago that was able to infiltrate in. And that's really what you want as a grower, is because we may not get timely rains. You want that rain to stay in the field until your crop grows longer roots and be able to access it. Well, right now, if some of the degradation has happened and the soil health isn't there, it's washing to the ditches and it's leaving your field, and you're never going to have the opportunity for the longer roots to even reach it. So that does lead to crop yield decline, and that's never a good thing, because we want you to have the best return on your investment possible. You spent money on the seed, you spent money on rolling your tractor through there and planting it, you some labor, you put some fertilizer and lime down, and because of the things above this, you still aren't reading that total potential that field can do for you. So then eventually there can be some issues with, even though you're putting the fertilizer out there, because the health of the soil has gotten so bad, it's still not able to even access that fertilizer and nutrients that you've applied. And the crop yield will continue to drop down. So that is how easy it is to happen. Here's a good visual of a healthy soil with water being able to infiltrate down. You don't have that surface crust on the top. And then on the other side, we get a surface crusting when we have, the degradation of your field and your soil, and the aggregates have been destroyed. And then just that all those water leaving the field, we know how important that is for making everything occur for your crop. So what kind of soil would you really want? Would it be letter A, letter B, C, or D? We've got some people in the crowd, so how many people would pick letter A? Letter B? There's a couple of hands going up. Letter C? Or letter D? Okay, there's probably most hands for that one, but don't feel bad for anyone. This is a trick question. Because you should say, I haven't done my soil health test yet. So looks can be deceiving. And so we're gonna keep walking you through some things about, why it's important to do a soil health test and start looking at these metrics in addition to like your chemical test. So I really think a healthy soil is just really gonna help in the long term of making you more productive and the return on your investment. So that last thing I read about when your soils start declining is you're not gonna be able to get the nutrients into your crop, even though you're putting it out there. That's a pretty big deal, especially with fertilizer prices these days. So ultimately, a healthier soil, and like I said in the beginning, this can actually happen a little bit quicker in some soil types than others. Don't ask me specific ones, but we can correct this damage, so that's a really good thing. You're going to be able to produce higher quality crops to feed your livestock. You're going to have higher water infiltration. So in between rainfalls, it's going to stay within your field and make it accessible later to a growing crop. It's going to take less horsepower to till that field. I know some of the people that I've worked with on soil health, they've noticed even going out and pulling soil cores, how much easier they notice that is. So I'm not in a tractor like you guys are, but you'll be able to notice that as you progress in your soil health adventure. Lower weed pressure, so that definitely is a less herbicide that you have to put out and pay for, so that's definitely a good thing. Higher yield or better yields than you've been able to get. So what some people have noticed is even though they're doing good things for their crops, they've kind of plateaued. And that could be because some of the degradation that's happened in the field. So if we can get back to fixing the health and the biology of our soil, will we be able to get off that plateau and get some yields going there. Healthier, vigorous plants that are better able to resist diseases and insects. So they've got all the nutrients that they need as they're progressing through the growing season. And soil health is a very real thing. So I've talked with lots of different types of people and growers and crop consultants and fertilizer reps out there. I try to describe it as what is soil health? When you drive by that one field and there's seagulls and there's wildlife in there, and if they are out there tilling up the soil, it's that earthy smell that's there. Versus when you're going by another field and you don't see birds and stuff there because there's nothing for them to get that advantage from. So that's some of the stuff that's out there, and Wisconsin does a really good job with soil health because we already do have a pretty diverse crop rotation. We have the ability or do have access to manure, and manure is a really good thing for soil health. And I would say working at the lab, people here in our state are doing a really good job looking at the chemical aspect of it. So here is a diagram of what all goes into soil health. That is one aspect of it, because in order to keep the bacteria, the worms, and all of those smaller organisms cycling, you guys are actually feeding them a little bit by maintaining good fertility in your fields. And good pH as well, because they're very sensitive to pH. But then the two things that are added to that, if you were to do a soil health test, is the biological components of it. So we put through one test, and Jim will explain a little bit in more detail, but one of them, a CO2 respiration test, and it kind of lets you know the activity of the bacteria that are present. So if there's a lot of bacteria there, the number will be higher. That means you're really good at high potential soil health. If that number is quite low, we have to maybe look at some ways to improve the soil health. And then the physical components of it too. So there are different ways to look at how those aggregates are and how they can bounce back to the thing in bulk density and beyond. So from my perspective, agronomists and farmers, we've always been trained to feed our crop. And I think there needs to be a mindset shift to we also need to feed our soil. Because once you start feeding your soil, and that is the header up on the screen, is we need to start thinking C and PK. And the C stands for carbon. And I know carbon's been a hot topic and everything, but carbon is really important for soil life because that's their source of energy. So where does it come from? It comes from plant residue breaking down, and most importantly, I think it's a lot of the root material that breaks down that stays there. We don't harvest it, we're not pulling up the root, but that's really important to the cycling of a lot of our important nutrients, the nitrogen cycle, the phosphorus cycle, the potassium cycle. And if those cycles become more activated, it just makes more nutrients and stuff available to your crop as it grows. And then good management can really create a resilient soil for you guys, which is better able to react to a lot of this extreme weather that we might have. So when it goes from really cold to really hot, or we get a very drenching rain to maybe a little bit droughty, that soil is going to be better able to accommodate between those things. So next, I'm going to have Jim come in. He'll be on the video screen, and you'll hear his voice. But he's going to take us on a deeper look about some of the exact information from your fellow growers from Fond du Lac in year one of the soil health adventure.
Good morning, can you all hear me?
You can, thanks.
Good. I can hear you well as well. I can hear the audience too, so if you have any questions, go ahead, feel free to interrupt me. If I don't respond right away, Chris will let me know as well. My name is Jim Friedericks. I've been working with Extractable Laboratories for almost 10 years. As my title said somewhere up front, I have a PhD in soil science, soil fertility, and I've been working in soil testing most of my career, including when I was in graduate school managing a soil testing lab in Virginia. The idea of soil health was something that we sort of batted around a little bit when I was an undergraduate back in the 70s, but the term we used then was soil quality, and we talked about the physical characteristics quite a bit, not very much about the biological characteristics of soil. And so now that soil health has become important in our conversation and our management of the soil, it's good to hear, it's good to focus on the biological components as well as the chemical and physical components of the soil analysis, and giving ourselves an opportunity then to really understand more of what's going on in the soil and how we can manage it. I'm going to go through two different sets of information. The first part will be a little bit of a description of the tests that we use, focusing primarily on carbon and water-soluble measurements. And that will be based on some research that we did here in Iowa with the practical farmers of Iowa. We had a site in central Iowa where we went out and sampled quite extensively and got research quality data out of that I can talk about. And then I'll bring in results from the samples that you all ran this last year. Becky gave me information so I could pull that data up and compile all that information. It's not all the samples, but I did focus on those samples where I had more than at least two, and in most cases 3 samplings across the summer, and use that information to give some summarization of what's going on. Hopefully from this, you'll be able to understand some of the soil health measurements, what they mean. And like I said, I'll be focusing on water-soluble portions, carbon dioxide respiration, the soil health score, which is a kind of made-up number, but it's a number that's helpful. And then the mineralized nitrogen, which is an estimate of what's going to come out of this as we go through. You'll understand more as I explain that. So, Next slide. This is the map of the farm where I did the research this past, well, it started in 2018, and we went out 4 times a year to collect samples from these different sites. At each of those blue dots, the light blue dots represent the ones we started with, the darker ones we added in subsequent years. At each of those blue dots, we collected 10 cores, and then in most of the data I'm showing, we combined those 3 points as one location, and may or may not have summarized that over the 4 years. The 4 sampling times were soon after crop emergence, considering the corn crop. July would be like V10, so the corn was growing vigorously. The September harvest was in black layer, right after black layer of the corn crop or adjacent corn crops, and then obviously November was after harvest. Next slide. The land, I didn't point out very well. There's 4 different classes of land. One was a crop. Could you go back to the other slide? That's be helpful. There's a row crop area down the bottom right, which is the bottomland of this farm. Right next to it is an ungrazed CRP land. And so those 2 sites are quite similar in soil. One is just the toe slope of a ridge right next to the field. And then the grazed CRP and main pasture are areas on top of the ridge, different ridges, but similar soil. One, the main pasture, was right behind the barn where they got 50 to 100 years of manure applied every year. That's the easiest, quickest place to spread the manure. And so that was a well-manured area, and it was used for pasturing whatever livestock you grew. And then the other CRP had been a CRP for 5 years prior to these experiments. Okay, thank you. So these pictures are taken the same day. The cropland, right, first samplings in the row crop was corn that year, corn soybean rotation. Then the CRP ground down by the cropland, and then this third picture is the pasture, main pasture up by the farm. And you just see the difference in quality of growth here. Looking at the soil test values, again, the row crop and this ungrazed CRP are the most similar soils. Organic matter is roughly the same. Phosphorus levels are very low across the field except for that pasture. Potassium was quite low in the cropland and in that ungrazed CRP. And the CECs are similar as well as the bulk density. Comparing the pasture and the grazed CRP, those two are similar again. Organic matter is roughly the same, above 3.5 or above. Phosphorus and potassium obviously higher where the manure has been applied historically, and the CEC reflects that, the organic matter reflects that a little bit as well. And that has the lowest bulk density. So that would be just looking at how we read a soil test. That's a classically good soil. The row crop, unfortunately, is probably the worst soil on this site, and was least well managed of all the sites. Looking at the soil health score, which is a number I said that's kind of made up number, but it's an established calculation that Dr. Haney out of Texas came up with this way of calculating the number. So it's well used and can use to compare fields one to another. A number less than 15 is probably not a good number. A number between 15 and 15 is where you would expect. And so the two better sites have better scores. The 2 worst sites have worse scores. The row crop being lowest in soil health. And you can, that reflects kind of how you look at the soil test results on that too. Thanks. We measure carbon respiration in the soil. What this means is that we take the sample and when we get the sample to the lab, we dry it and grind it so that all the samples are dried. And then we take a part of that sample, put it in one of these little jars, add some water to it to rehydrate it, cap it, and put it in an incubator for 24 hours. And at the end of 24 hours, we attach it to this machine on the lower right that says steady state. What that does is, or on the lower right, you can see the that vial that has the tubes attached. We just take all the gas that's been trapped in that vessel and read the carbon dioxide concentration in that. So we can measure how much carbon dioxide was produced by the soil that was remoistened after 24 hours. And value again, typical ranges are 1 to 300. And next slide. The typical, a good value would be 50 to 150 ppm carbon dioxide. So the respiration rates of these soils reflect kind of the numbers that we saw in the soil health scores. The row crop has the lowest respiration rate on average, and this is average over all 4 years, over all sampling times. And the respiration rates of the pasture was the highest. The others being in between those. That just indicates that that pasture had a lot of biological activity that was stimulated when we brought back into the lab and had water in the soil. It just had a flush of growth, produced a lot of carbon dioxide, and that reflects how readily that organic matter or those organisms can use that organic matter to chew up the carbon and produce carbon dioxide. Whereas the row crop had the least biological activity, as illustrated by this respiration rate, lower organic matter as we saw, and just the less vigorous soil health as represented in the organisms in that soil. Next slide. The other test that I want to focus on is the extractable carbon to nitrogen. This test, we take some dry soil, shake it with water, filter it, and then analyze the amount of carbon and nitrogen that can be dissolved in that process. And we measure those two components at the same time using this instrument, which is a carbon and nitrogen analyzer for the liquid samples. So from that, we get the water-soluble carbon and the water-soluble nitrogen. We use that to calculate the water-soluble carbon to nitrogen ratio, which again reflects how easily that those organisms in the soil can use that carbon to generate energy and generate CO2. And it's regulated by the amount of nitrogen. If there's not enough nitrogen, then it's hard for those organisms. They won't thrive. If there's too much nitrogen, then they'll start consuming any other carbon source that they can find, not just what's easily available. They'll start using more stable, more resistant carbon as they use up the nitrogen. Next slide. For these samples again, that same pattern emerges. The row crop has the lowest water-soluble carbon and water-soluble nitrogen, and the pasture had the highest water-soluble carbon and nitrogen. Notice how roughly equivalent these numbers are. So you have 169 ppm carbon and 17.6 ppm nitrogen. That's a ratio of about 10 to 1. And that was true for each of these different locations. So keep just all that number in mind, 10 to 1 to that carbon and nitrogen ratio. And as I said, you might think that the row crop would have more soluble nitrogen available because it's fertilized, because there would be an application of fertilizer. But this test, we're actually focusing just on the organic portion of that carbon, of that nitrogen. And so the numbers are a little bit different. There's a nitrate component and an organic nitrogen component. And so this looks more at the organic nitrogen component and measures that availability. Next slide. See those numbers, CDM ratio numbers, how close they are to 10, except for that CRP ungrazed, which went up a little bit. But those are good numbers, kind of what you'd expect for a healthy soil. Even the row crop has a fairly good carbon to nitrogen ratio. I did see some variability in that throughout the summer as I measured those. The ratios were lowest in the spring and highest in the fall. And My understanding of that is probably there's a higher flush of nitrogen earlier in the spring that the denominator is nitrogen, so if that number grows, then the C-to-N ratio becomes smaller. And so that's just because the soil's been sitting over the season, over the winter, nitrogen in organisms have been working and everything has been solubilized, so there's more nitrogen available. By July, that nitrogen is used up. There's the amount of nitrogen in relation to the carbon is lower, so you get a higher number. And then it just fluctuates up and down as the crop grows, and then finally after harvest, as the organic material starts to senesce and break down, there's more carbon available in soluble form than there is available nitrogen at that time. So there is some variability. I'll point that out a little bit in the next slide when I talk about the Lac Samples. So right to the next. The last thing I wanted to point out on this research set is a measure that we can then generate by looking at the respiration rates and the C-to-N ratio, but also the amount of carbon and nitrogen that are soluble. We can calculate how much nitrogen will potentially be mineralized from that organic source in the soil. And by organic, I mean organic matter, humus, easily decomposable plant residues, those sources of organic nitrogen that are present. So you can see the row crop, there wasn't much organic matter in the soil to start with. It has a very low potential to release more nitrogen throughout the growing season, whereas the pasture and the grazed CRP actually had quite a bit of potential. And that nitrogen would become available as the season progressed and the crop would use it. I should note that the pasture had a fair amount, maybe 25% of legume in the pasture mix, red clover, some white clover. The CRP grazed had a little bit of red clover, but not much. The CRP ungrazed had zero legume in it. Mostly rough warm season grasses in that. So why that has a lower nitrogen mineralization, probably just a lower nitrogen content in the lower soil health score kind of leads to that. There is a measure that we also calculate that is related to this, which tells you how much phosphorus could be available over time from organic matter. And these numbers are generated from the principle that carbon to nitrogen ratio is usually 10 to 1, and then nitrogen to phosphorus ratios are also usually 10 to 1. So carbon to phosphorus would be 100 to 1 ratio. So those numbers are in the background of why these calculations can work and why they do work in practice. Next slide. For the Lac Samples, like I said, I received the results, or we had the results. I received the identifiers for them. Had about 1,560 samples, and I went through those samples and found those of you that had submitted multiple samples through the season, they came down to about 10 or 11 that had at least 2 sampling occurrences and some 3 on the same field. We had 3 different times. Generally, they were in May, June, and July, late July or August was the last one. This is the data from that. If you just look at the overall average column first, good soil, good pH, 2.9% organic matter, good phosphorus availability. On average, potassium was adequate to medium to high. That's an average number, so there's some high, some low. But CECs on these, 15 milliequivalents per 100 grams, that's good. Good CEC. And you may not have gotten this value in your report, but the CEC and the calcium kind of drives that CEC number. And so I noted that when I looked at more carefully at the samples, there was a division between those fields that about half the samples received manure and half the samples did not received manure either in the spring prior or the season prior to the sample. So I segregated them that way, and I saw some difference that way too. Particularly looked at the CC and the calcium. The samples that received no manure are different than from the soils where manure was applied. I don't know these fields and your history well enough to know why, but there's a difference there. And so when I'm comparing manure to no manure, bear in mind that I'm not comparing the same field with without manure, but these are distinctly different fields with different soil characteristics. But overall, good soil, and good averages there. If you look at the soil health score, and I wanted to point out the chemical test because this is counterintuitive. Why is the manured soil having a lower soil health score than the non-manured soil? And I believe it's because they're just different sites, different fields, different management. And neither one is a bad soil health number, but they just come up different. And really what you want to do with the soil health testing program is use this base number for your first year test, and then look at your numbers over time to see how your practices influence the soil health going forward. Thank you. Next slide. Looking at the same grouping of samples and the average C10 ratio. Do you remember what the average ratios were on that research set? Somebody say the number. They were all around 10.
10 to 1.
And these are all less than 5. This indicates not anything terrible. This just indicates there's a lot of nitrogen available in those soils in relation to the amount of carbon that's there. So it's a really low number, something that can be kept in mind and something that can be used to your advantage. And I'll explain that as we go through. The respiration rates for this, again, remember, reflect back, the respiration rate for the research site that was cropped was in the 70s. The respiration rates for the land that was in continuous pasture or CRP was well over 100. And so these numbers reflect respiration rates that you would see in crop land. So I'm not saying anything wrong. Excuse me, there's nothing wrong with these numbers. They just reflect the management that has occurred on these locations. And again, an anomaly of this data set is that the manure values are a little bit lower than the non-manure values, but again, it's different sites, different locations, different soils. Next slide. So rather than going through all the different slides, I decided I would just compare all the data, looking at manure versus non-manure for each of the different tests. We've already looked at soluble CN, which is that really small stack of bars there. And there's really no difference. They look the same on this scale. They were a little bit different on the closer scale. The soil respiration, the manured, again, is a little bit lower than the non-manured. But the opposite is true for the water-soluble nitrogen and water-soluble carbon. I think that's probably characteristic of the manure application. Water-soluble carbon reflects that carbon which is easily dissolved, easily made available. When you're applying manure, you're applying easily broken down components to the soil that have already gone through an animal. And so they've been broken down that way. And then there are smaller molecules that can be easily utilized by the organisms. And so it releases water-soluble carbon easily and nitrogen. And so those are reflected a little bit here with what you see in the data in the non-manured sites. The mineralizable nitrogen, which is the amount of nitrogen that you can anticipate using again here. See how well it reflects the soil health score. And those two are related mathematically in the way we calculate that. So as that soil health score changes, that mineralized nitrogen also changes. And so that's why that nitrogen value is higher for the non-manure than it is for the manure. Again, keep in mind, it's different kinds of soil management that's taking place on those. Next slide. Sorry, this is a messy slide, and I apologize for that, but I just want to use this to look at the variability of the values within the text. Now, we said that the manure respiration rate was higher for, the carbon dioxide respiration rate was higher for the non-manure sample than it was for the manure. So if you look at that light green, the pairing sample, these are meshed in pairs. So the pair that is light green and light blue, which will be the second pair from the left. The blue box represents the variability of the values that we found when we measured the respiration rate from the non-manure sample. All I'm trying to point out here is there was a lot of variability in those measures. And so even though the average was higher, it reflects just more noise in the numbers that we got. And so that higher number is a bit of an artifact. Whereas the manure samples, that variability is less, and the samples are fairly consistent. So again, keep in mind that these numbers are averaged across a lot of different sites. What you want to do is take your numbers and look at them however often you sample this way and see how you progress over time when you take your samples from season to season. Next slide. Or from year to year. I did want to look at how the time of sampling influences the results. The response is a little bit mixed on that. The respiration rates, again, I think there's more carbon availability. Well, there's not more carbon available in the first sampling, but there's something that's taking place that allowing that to utilize the carbon more readily in the beginning of the season, whereas later on those numbers flatten out. What we do see is some variability in the water-soluble carbon over time. Again, different from what we saw in the research set, but there is some variability. A question that you might have, which I've been asked by others when they look at this kind of data, is when's the right time to collect the sample? And Becky's asking this question. And the answer is the same time you collected the sample last year. So it's not important to collect all. It can be instructive to collect 3 samples in a year, but I think for historical purposes, if you want to go over a 5-year period, it's much more important to collect the sample at the same time every year. So if you collected it right after planting or this May sampling time frame, go back, it's probably the same time, kind of try to mimic the same environmental conditions that you had when you sampled the first time. And Becky has those records, so it was soon after rainfall, and you can go back and try to sample early in the spring and soon after rainfall to get results that will be similar to what you had initially. So those kinds of variabilities will influence the results somewhat because we're looking at water soluble characteristics. We had a lot of rain, and rain will move through the profile, and you just sample 6 inches. Maybe the water soluble components move down a little bit. You may influence that value as you before or after rainfall. It may come out differently. So just a comment on sampling time and how season does influence the numbers that you can see from these results. Next slide. The mineralized nitrogen. This is, I think, maybe one of the most valuable, immediately valuable results for you to consider from the soil health test. I think the soil health characteristics, the soil health score, the carbon nitrogen ratio, those are important. They're long-term numbers that you can manipulate over a longer period of time. The mineralizable nitrogen is something that you can manipulate over time, but it's something that you can take advantage of this season. So again, you may want to sample early in the season so that you know potentially how much nitrogen is going to be available to you in the season from the soil organisms and soil organic material that you have. So on average, 67 pounds of nitrogen was available per acre for this season, for last growing season, over the period of the growing season. And that number changed between manured and non-manured, again, reflecting characteristics of this management and samples themselves. So those numbers on the mineralizable nitrogen are in pounds per acre. We do report to you the soluble nitrate that's in that same sample. And in this case, these numbers are reported as parts per million. The way, if you took a 6-inch sample and that was what was submitted and analyzed, you can take that number and multiply it times 2 to get pounds per acre of nitrate nitrogen that's available at that time of sample. So you all know that rainfall and leaching and all that influences nitrate that's in the soil when you sample, but that was there at that time. So there's roughly 11 ppm or 22, 24, 25 pounds per acre of nitrate in these soils that will be utilized by the crop. This was averaged over the season, so maybe it was probably, I think it was higher in the spring than it was later in the season, but just keep in mind that's that number. Therefore, I think if these numbers reflected the spring nitrate content and the mineralizable nitrogen potential for the non-manured ground, you had 85 pounds of nitrogen that you could take advantage of in the growing season. To reflect how much nitrogen that was applied, the nitrate did. The mineralizable nitrogen doesn't reflect fertilizer nitrogen, it reflects organic nitrogen that will become available over time. So you can dial back your nitrogen application based on the amount of nitrogen that your soil has stored up and will make available.
Hey, Jim,
Yes.
I have a question. So when our team was out pulling the samples, Becky instructed us to pick any trash that was immediately over the probe away. So how would that affect the mineralizable end? If there's just like organic matter or like worm paths on the top of the soil, is there any way to quantify what that might be in mineralizable nitrogen?
Two parts of this answer. The procedure to remove the trash, especially the large pieces of organic material, is the right advice, because that breaks down so slowly over time that it's probably not contributing. You may be tying up some of the nitrogen over time, but it's a minor effect. And so what we're measuring in the water soluble nitrogen is what's actually in the soil and from the organic matter in the soil. So that's a good estimate of what's potentially there. Worm castings, yeah, that's something if you had a lot of that and you were able to include that in the sample, that would be useful to include. But generally, you want to remove the surface litter material at the time of sampling for this kind of soil health test after planting, because that material on the surface really will contribute to the current crop's nitrogen availability or the current crop's organic matter. It does decay. Don't get me wrong. It does decompose and it does contribute. But what the crop is utilizing is what's available immediately in the root zone, and so it's not a major contributor. I get it?
Yeah, I wasn't questioning the procedure, just more curious if that played any sort of factor. Yeah, so thank you.
Yeah, I think you want to leave as much organic matter in the field as you can. Some people, it's possible could you do a soil health test in the fall? I think that is also possible. In that case, it's more, the potential mineralized nitrogen is probably less predictive that far away from the next growing season. It's better to do that in the spring.
Thank you.
Yep. And I think this kind of ends what I want to say. Is there any more questions on this portion? And then I'll turn it back to Chris. Next slide is, yeah.
Okay, thanks, Jim. So as you're sitting there and like Jim did a pretty good summary of like a lot of the samples all together, is kind of look at these two columns here and which side do you have more check boxes for? So we have things on the left side that have a tendency to increase your soil health. So no-till or minimum till, cover crops, diversity in your crop rotations, specifically like trying to add back in small grains. They do really amazing things because of their root mass that they can just add to the field. Increasing your biomass in your field with above ground variety equals underground variety. Adding perennial crops into your crop rotation. Manure, increasing your crop residue, so maybe just raising your combine head a little bit higher to leave some behind. Increasing or just different things for integrated pest management, weed control by cultivation and mulching, or some people are able to utilize planting green. Rotational and prescribed grazing on some of your fields, and then variable rate and prescription fertilizer use. Or there are things on the other side where you maybe have a father-in-law that just needs to get in the tractor and is doing recreational tillage. And maybe you don't necessarily need to do that tillage out there. You can get away without it. Fields that are left fallow in the off season, bare soil that's left that could have eroded either by wind or water erosion out of season. When there's continuous corn or monocropping with row crops, annual crops, extensive or excessive fertilizer use, excessive crop residue removal, and then just broad spectrum pest control when maybe some integrated pest management could be used instead. So those are just a lot of things to put in perspective of the different things that can help soil health, and choosing those ones that work for you. It's not like you have to do all of them, just picking one is gonna help. So again, to summarize, what are some of the things that really do help with the high quality soil or improving soil health? Remember earlier I said you guys are doing great things by just maintaining your fertility. So we have to start thinking feed our soil, and when you're feeding your crop and keeping proper pH, that is definitely going to help your soil life as well. The second thing to that was thinking C and B thing. So the carbon aspect of it, is it a cover crop that's going to add more residue in? Is it adding that small grain in? Is it less tillage that's going to help provide more carbon for your soil life? And then really work toward keeping soils covered year round. Heard a really cool thing from another NRCS person in Wisconsin where their friend was a pilot and was able to take some aerial pictures of an area that they work in and showed it to them over several years and how much more there is covered over that county than there ever was in the past. And that person he's just a pilot and he sees that just fine. So I thought that was really cool. He shared that with that NRCS staff. And then adding different sources of organic materials to your soil. So that can be done in different ways and different practices, and then reducing tillage, and then preventing compaction. So compaction does the same thing that it does to soil life, that it does to your crops' roots, and it does make it harder for them to access the nutrients and complete their cycles. So compaction is bad for soil health So I do have a success story to share, and he was a speaker probably 3 years ago at the Wisconsin Cover Crop Conference. Rick Clark from Williamstown, Indiana, he farms 7,000 acres of corn, soybeans, and wheat. And then plants his corn and soybeans no-till through a living crop of cereal rye. That cereal rye is then creating a moisture catch, it prevents weeds. And then as that cereal rye is decomposing, he gets it at the right crop stage, but it decomposes quite quickly for him. And those nutrients are returned to the soil and then become available to that cash crop that he's planted, usually corn. And he's a numbers guy, so this is how he has some pretty impressive numbers to share. So in 2018, he burned less diesel fuel than he did in 2011. His nitrogen fertilizer went from 220 pounds per acre to 110. NAP use went down 91.8%, and he's completely stopped applying potash and lime completely. So it's kind of getting his soils back into a balance that they're doing the nutrient cycling just by decomposing a lot of the crop residue that he's leaving behind. His chemical cost from 2018 went from $18 per acre, and he was ballparking that for 2019 season to be about $5. And then for his size of operation, that all totaled up to about $632,000. That's pretty eye-opening. So he called, and one cool thing that he does is he has a regen year. He knew that his soils needed it, and he will take 1 year of his crop rotation just for his soil. He's not pulling a crop off. He doesn't have corn to take to the mill and sell for bushels of grain, but that is purely to feed his soil and bring it back to creating all of these advantages that he's had. So he does have a website, farmgreen.land, if you want to look at his website. So another thing that we have that's kind of related to just soil health in general, because one of the things that really does help soil bounce back pretty quickly and keep it covered is the addition of cover crops to your crop rotation and having them out there. So we do know that cover crops are able to trap nitrates or sequester them by uptaking it when maybe we don't want rainfall and snow melt to take that out of our field. But one of the questions is we never really know how much. And so there is the cover crop biomass test. This is going to tell you nitrogen as well as all the other key nutrients, how much it took up. And then it's going to also provide like that C to N ratio and kind of give you an estimate, is that going to be hard to break down and maybe we need to add a little bit of nitrogen, or is it going to return quite quickly to the field? So this does work really well for cover crop mixes. It doesn't have to be just 100% rye. It can be a mixture that you have. And then based on the different species, you'll get a better idea of like kind of that nitrogen credit that you might be able to take from it. So it's a little bit different of a sampling. So you'll print off the lab sheet. It's just a plant tissue sheet. You'll want to know when you need to take the sample. So if you have one that's going to winter kill, you're going to try and do that before frost in the fall. If you have one that's going to come back this spring and grow in the early spring, is make sure that you take your cover crop sample before it is going to be killed, or you plant green. So just prior to planting, and that's going to be the best feel for what nutrients out there. A little bit different in the process is you're still going to pick a representative area of the field, and then as the diagram shows up there is like a 2x2 area. Scissor clip all of the vegetation that's there, lay it on the tarp, and then weigh that in the field or back at the farm. And make sure that you put that on the tissue form. That helps us give you the best estimate of pounds per acre of the nutrients that we analyze out of it that is going to be returned in the field from that cover crop. So it's been really helpful with people as they've been going on their cover crop adventure to make sure that they're hitting the right nitrogen applications and they're not hurting the next crop. And it's pretty eye-opening to see what that cover crop is going to provide to the next half drop. And then a second one that we've been doing at Express Laboratories is some of our soil health ad tests, and most all of them are related to carbon testing. So it's been a very hot topic, and our company is definitely invested in, we feel that this is something that farmers in the long run are going to either look at or potentially utilize on their farm is carbon credits. So there's a total carbon that will show you both inorganic and organic forms of carbon. The one that most carbon tests want is just total organic carbon. And then we also have a total nitrogen. You can specifically just look at your C to N ratio in your soil or your organic C to N ratio. So lots of new things coming out, and we're just trying to help you guys out there. And anything that is really improving soil health overlaps, and it's going to help you with increasing carbon too. So a lot of the steps that you're taking is you get to talk to or investigate carbon. If you're doing good things with soil health, it's going to also be helping with carbon too. So overall, I know all of us here, we want the farmland to be here for our grandkids, and we want that farm to continue. So improving your soil health is going to help create a resilient soil, able to withstand extreme weather, and a soil that's going to do more work for you. And it's only if you have a healthy soil and you're able to keep it in your field. So, and Jim, we'll take any of your questions, and thank you for listening and participating, because you are one of the year one participants in the soil health program.
I was just thinking about the manure, and maybe next year we gotta get more definition of the manured fields versus the non-manured, because I think we just collectively asked if there was a manure application, and I don't quite remember if we teased it out, if it was a fall application versus an early spring application. We didn't tease out if it was a liquid application versus a pen pack, or, so that might be something that we need to redefine a little better when we collect next year's information.
I'll just say some of the information I had, some of it said manure was applied yes or no, some gave the tons or gallons, and a couple of them also indicated weighing it. It wasn't consistent.
Right. Yeah. So when I was looking at the results, I was like, and then the other thing that I noticed too, after looking at some of the results after the May sampling, the very first one is not only looking at when the manure was applied, but were we getting some clutter in there from when they had just possibly put on pre-plant nitrogen, and how many days prior to us sampling that could have caused some of that mineralizable and or nitrate numbers to be a little, weird.
Yeah, I assume the nitrogen was there from fertilizers. No, yes, that's probably at least. Maybe in all of them, at least in the second and third ones.
I think that is one thing with soil health. When you look at an individual sample, there's so much that one test, you have to really dig into a lot of what they just brought up, management that goes behind some of the reasons why it might be like that, as well as the history. So if you have maybe newly purchased land and you don't necessarily know the full history of it, you may find that that's going to be different than land that you've always had and managed your way on your farm, because it kind of has a different effect on the soil health characteristics of it.
The other thing that, now keep in mind, we're gonna keep the May, July, September sampling to stay consistent so that you have something to compare with your baseline going forward into this spring. But that's why we took as much weather data, and we took soil temperatures too, because May was very cold and dry this year, so next year May might be a deluge of wet rain. So when you're comparing May 21 to May 22, they might be like, so that's why we want to collect these on the same fields for a few years going forward.
Jim, how did you guys deal with that in your Iowa one, because you're several years into that one?
We kept track of the information, but we didn't do as good a job as we could have in trying to match weather events. The illustration of that is in 2019, in July, I went out to sample, no, it was Black Bear. Went out to sample, and it had the forecast said it was going to rain a little bit, so I wasn't too worried. It rained 1.5 inches at the farm just before I got there. So we were waiting for the mud, taking these terrible samples. But that's when we sampled.
I got a question. You always hear about like farmers such as Rick Clark that have ratcheted back their inputs, but the most interesting question is how much and how long did it take you to figure out how much you could actually do responsibly? So let's say we have a farmer that has positive results on their tests and they want to start playing around with ratcheting back. Do you have any opinion on how much they should play around with the first year?
I think a starting point would be to look at that mineralized nitrogen as a guideline of what numbers you can start working with. I totally understand the reservations of not going the whole way with that, but if it's possible to do some strip trials on your farm, then you could graduate that. Let me cut it back 85 pounds. Let me cut it back, or start at 50 pounds. Let me cut it back 50 pounds and 25 pounds on these two strips and see if I get yield differences, if there's a knock on that. And none of the data I presented to you were side-by-side comparisons of a management practice in the same field. And so that's, these values are indicative of what will happen, but what actually happens in your own field under your own management. I think my best advice is if you can segregate or do strip trials or divide a field with the practice, that would be the way to start, just so you have your own baseline for direction. And maybe you're bold enough to say, I'm going to come back here to 50 pounds of nitrogen this year, but I'm going to do 2 strips of the normal practice. However you feel comfortable. That'd be the way to start, but it does take time to get comfortable with that. And I think Clark's experience, as well as others, is that first couple of years you just sort of start getting a feel for what's going to make a difference and where you can come back, and then you get more confident in what you're seeing, and you can actually start dialing it back in a couple of years.
Yeah, I totally agree with that. Thinking, aside from this, a lot of questions about microbiological products that are out there, and you're like, oh, this increases my nitrogen, should I put it out there? And I'm like, you should probably still do a strip trial. Don't just, take the word for it. We know nitrogen, any type of nitrogen product is so tied to Mother Nature that, I would try it on like 6 fields, and if it worked on all 6 of them, I'd be like, heck yeah, that's a good thing to do. But yeah, definitely need to do the strip trial of doing nothing and seeing how your soils react to it.
No. Building soil health is a long-term process. And so you may not see dramatic changes in a couple of years, but you will see changes in 10 years. And so, just keep that in mind that you can't do everything next year that is promised by this this webinar, or, you know, the best case scenario, you need to, for example, you know, if I start applying more manure on a field, when will I see those benefits in soil health, or if I manure and cover crop, when will I see those benefits? You might start to notice some changes in a couple of years, such as water infiltration and moisture availability. Those are probably the biggest impacts that you'll see. Is my field just doesn't dry out as quickly as it used to, like, you know, those sorts of things. And of course, there's the, you know, potential for nitrogen. If you really want to get into it, you can do some some other measurements of your crop as the crop grows. Corn, for example, take early tissue samples and see how your nitrogen is your soil providing enough nitrogen as you go into the season, and be ready to come back and side dress if you need to apply more.
So Jim, this group, this was year one of the project. And do you have any advice for, like, as they get year two results of what are some of the top things you would suggest that they look at on the soil health test?
I would look at the respiration rates and the soluble carbon to nitrogen ratios, the CN ratio that's on the soil health test, just to see if those are changing. Soluble carbon, soluble nitrogen, those will fluctuate up and down, like I said, with changes in moisture level in the soil, or, you know, recent, climate will influence that fairly fair amount. But the ratio of those two should be fairly consistent. So if you start to see that number shift from the average here was in the 4.5 to 5 range. If it starts to move up to 8 or 9, you know, keep that in mind. What you really want it to be around 8 or 9. That's kind of the target, representing a good balance between nitrogen availability and the use of carbon in the soil. So I think what that indicates for this average group of samples is that there's a lot of nitrogen available in these soils for some reason compared to the amount of carbon that's there, and potentially that could be taken advantage of in next year. But in terms of metrics over time, from year 1 to year 2, you may not see changes. You may see changes in the wrong direction, which I saw when I did that research. So first year, I thought I had it all figured out. Then I did the second year. It totally confused me. But when I averaged all 3 years together, it started making sense. So it's a process. And one other idea that I've heard that we've had sort of successful was comparing adjacent fields where one is in a pasture and one is in cropland. I had that sort of in that cropland in unraised CRP. Or if you don't have that, go into the fence line, the fence row, pull a soil sample there, and compare it to your adjacent crop situation, and just see what is the influence soil health given no management versus the management that I'm normally doing.
Yeah, that is a really good one. I was talking with the crop consultant about, he's 3 years into a grower going from just conventional tillage and no cover crops, whatever, and they're 3 years in. He's like, I should probably take a soil health test this year. And that's what we talked about is, you know, what is maybe the potential of your soil for soil health is, that undisturbed fence row is going to be a pretty good one to use. And then we talked about a neighboring field that maybe is still conventional, that's the neighbors, to see if they can see anything of what the cover crops and the no-till has done in those 3 growing seasons so far. So that's another way to think about it, depending on where you're at in your adventure of increasing your soil health. Yeah, our contact info is up there, so feel free to reach out to Jim or I, or send your questions to Becky, and her staff. They do a really great job communicating with us, and we love the questions and stuff as well. So. Thank you.
All right,
Thank you all.
thank you. Yeah.
Zach, are you?
Yeah,